Hi, my name is Lynn and I'm a cloud engineer at Nebulaworks. My day-to-day includes using tools like Terraform to provision infrastructure as code. So the question of the day is, how do you keep your company's secrets secure when building out its infrastructure? If this is a question you've been pondering about, then you've come to the right place. Today, we are going to Terraform Vault on Kubernetes. So protecting and securing the assets of an enterprise is vital, especially when it comes to company secrets. By deploying Vault, users can depend on their passwords, certs and keys, and other secrets to be encrypted, highly available, and safe from outside attackers. By watching this video, you will have multiple Vault clusters running with just a few clicks of your keys. Alright, so for the objectives, we'll dive into the tools that we will be using in this deployment, and in the architectural overview, I'll briefly explain how these tools work together. So let's get into the prerequisites. First, you need an AWS account and the IAM permissions corresponding to that account to deploy the resources that we need. And then we need some tools installed. We need Terraform, Vault, kubectl, and AWS IAM Authenticator. If you want to learn a little bit more about these tools, I've provided links in the description below, and I will also go over them next. Lastly, we need the PKI setup. So you'll need to create a certificate authority and the self-signed certs needed for Vault and Console. Alright, so let's go over the tools. First, we have Terraform, which enables users to create infrastructure in the cloud as code using HashiCorp's configuration language. Vault is a secrets management tool, and Console is used as a storage backend for Vault. Lastly, we have Kubernetes, which is a container orchestrator tool. All these tools are open source, and besides Kubernetes, are created by HashiCorp. So let's dive into the architectural overview. Behind me, I have a high-level diagram of the tools that we talked about earlier and how they all work together. So in this box right here, I have our Kubernetes deployment, where we have one Vault pod and the 3 console pods serving as the storage backend for Vault. This is all managed by Amazon EKS, which is Amazon's managed Kubernetes service. In order to provision all of this, we will need Terraform, which is the tool that we use to provision infrastructure as code. So how do we interact with this deployment from our local machines when it's up in the cloud? We will be over here. Actually, let me put this over here. And we have our local machines, and we install AWS IAM Authenticator, which is a command line tool that enables us to use our IAM credentials in AWS to interact with AWS EKS. So with that, let's hop into the demo. Alright, so let's hop into this demo. I have here the URL to this repository. It's called HA Secrets, and I've already cloned it down onto my local machine and changed into that directory. So I'm assuming that you already have Terraform experience, so I'm not going to go into detail, but I've broken apart all of the Terraform files into the different resources. Like I have Vault stuff in here, console stuff in here, EKS, IAM, and something I do want to point out is the variables.tf file. So you will need to have the terraform.tf vars file created beforehand in order to run this. I've created same defaults for the first 4 here. You can go ahead and change them if you like, but what you do need to add are these following variables. We have gossip key, which is the key used to encrypt console traffic between members. You can generate this beforehand by running console keygen on your command line. And then the location of your CA and the console vault keys and certs that you created in the prerequisites, your AWS account ID, and then of course the pre-existing IDs of your VPC and 2 subnets. Also, you will need to add the IP address of your machine to allow traffic from your machine to Kubernetes in this format. The way that this deployment works is that it will create a kubeconfig file in your home directory and .kube, and it will name it after your workspace. One second. All right, so I already have one called config.linux, and if we look at Terraform workspace list, I do have a Linux workspace here. And this already has pre-existing deployed resources like Vault and Kubernetes. I'll show you that in a second. So right now we're going to deploy into the LD workspace. First, you'll need to export your AWS profile credentials, and then you can run a Terraform init. I'm gonna go ahead and apply this code right here in the LD sandbox environment. We're gonna be spinning up 29 resources. This is gonna take about 10 minutes, so I'm just gonna let this run in the background. And like I said earlier, I had already deployed Kubernetes and Vault on the Linux workspace. So I'm going to change over to that workspace right now. Also, another thing we need to do in order to communicate with that cluster, we will need to export our kubeconfig location as well as our AWS profile. So do that, and then export kubeconfig, and then we're going to point it to config.linux. And from here, we should be able to run kubectl commands to authenticate and communicate with our cluster. So I'll run a kubectl get pods, and we see here that I have everything running as of 84 to 86 minutes ago. I have 3 console storage pods that serve as a backend for my one Vault pod. And I'm going to go ahead and just port forward a console pod and a Vault pod to show you, or in order to work with our Vault. So I'll do this up here, kubectl port forward console-0. And then it's port 8500 in the pod, and then port 8500 on our local machine. Oops. I need to also export everything again. So the AWS profile and the kubeconfig. And then we can run the kubectl port forward again, and that'll work. So it's now forwarding. And then I'm going to do the same thing over here, only for Vault. So export your AWS profile and your kubeconfig, and then kubectl port forward the name of your Vault pod. And then Vault is running in port 8200. Now that we have the port forwarding in place, we need to export a couple more environment variables. We need to export the Vault address to be our local machine on port 8200. So https 127.0.0.1 port 8200. And then we also need to export the location of our certificate authority. So I have it right over here, and I'll just hit enter. From here, we can now run Vault status. And this is the status of our Vault pod right here. It is currently not initialized and it is sealed, so let's initialize and unseal it. I'll run a Vault operator init. And since this is just a demo and it's going to be destroyed right after this, it doesn't really need to be secure, so I'm just going to have one key. So let's save the root token export vault token equals that, and then run an unseal. Cool. So vault is now initialized and no longer sealed. I'm now going to put in some secrets in vault. So let's do a vault secrets list. We have a key value mount called secret, so I'm going to put my secret in there. You'll just run vault kv put secret, and everything in vault is a directory, like the users are directories, the policies, the mounts, everything. So that makes things really easy to work with in vault. So we're going to put a key value in secret and call it top secret, and the key will be Lynn and the value will be cool. Cool, so we have a success. Now if you wanted to get that secret, we would just do vault kv get secret, and I want to get the secret of top secret. And here we can see Lynn is cool. I did want to take a moment and just show in the web browser a couple of things, so I'm going to switch on over to there. So as you can see, I already have 2 instances running prefixed with Linux, the Terraform workspace I'm on right now, that has already been created. And we also already have Linux-Vault for our EKS cluster. And currently, we are building out the EKS cluster for the LD Terraform workspace. So if I were to just refresh this, we can see that LD-Vault is currently being created by Terraform right now. We also port forwarded the Vault pod to our local machines, port 8200. So we can reach Vault by just going to HTTPS 127.0.0.1, port 8200. And here, this is Vault from our EKS Vault pod. And it's asking for the token because in the CLI, we already initialized and unsealed vaults. So once the Terraform apply completes in the LD Terraform workspace, we'll be able to see the 4 worker nodes right here, prefixed with LD. All right, so let's go back to the terminal. And one of the most important things I want to show you is Vault's high availability capabilities. So if we run a kubectl get pods and then a wide look on them, we can see once again that console, there's 3 consoles and 1 vault. What that means is when you put data into vaults, it will go straight to console, and console is serving as that storage backend for Vault. So nothing is really being stored in Vault. If Vault were to completely get terminated, the instance or the pod, we would still have all of our data safe and sound with console. Normally we would have maybe 5 consoles as our storage backend, but since it's just a demo, I only have 3, but it will still serve the purpose I'm trying to communicate here. So I can demonstrate this by simply deleting the Vault pod. So I'll run kubectl delete pod, and I will delete Vault. And then I'm going to do watch kubectl get pod dash o wide. So already we have a new one running as of 17 seconds ago. So if I were to re-port forward this Vault pod, I'm going to copy it. Actually, it might still work. Let me check a vault status. Yeah, it looks like I'll need to port forward that again since it's a new pod. So I'm going to do kubectl port forward, and then the new name of the vault pod, port 8200. Oh, couldn't find it. Let's see. Oh, it looks like it's a new one. So I'll copy this. And then kubectl port forward. All right, so now let's do vault status. Initialized, yes, not unsealed. So I will need to find the unseal key again. So right here. Cool. Now if we do a vault kv get secret top secret, Lynn cool, our data is still there even though we had deleted the vault pod. All right, so the last thing I wanted to show was the finished Terraform apply of our LD workspace. So initially we had the issue where it didn't finish the apply completely because I had moved to a different workspace in the middle of it. But that would normally not occur because it would be two different developers working on two different sandbox environments, and it wouldn't be the same developer applying the same code in a different workspace. But even if that happens, no worries. You just need to apply or switch back to the workspace that was in the middle of the apply, run Terraform apply again, and it should finish the rest of it in about 1 minute. So I went ahead and did that, and it completed right here. And I exported the kubeconfig to point to my new kubeconfig and ran a kubectl get pods. And it shows that I now have a new vault pod ending in tvdvq. And this bottom part is still pointing to my Linux workspace. And it's a vault pod ending in c89qw. We also see that this cluster was deployed almost 100 minutes ago, and this one was the just completed one that finished about a minute ago. If we also go back to the AWS Management Console, we'll see if I do a refresh, it'll go from creating to LD Vault and Linux Vault are both active. And I had refreshed back here, and we now see the two EKS workers for both the LD and the Linux workspace. So with that, that concludes my demo. I hope you enjoyed it. Now that you understand how easy it is to deploy Vault in a highly scalable and available way, you can take this knowledge back to your team to start protecting your company's secrets. If you want more information on how to provision infrastructure in AWS, GCP, or Azure, please click the link above as we provide a number of DevOps consulting services. Thank you for watching, and see you next time.